Yo, doing thermodynamics basics. Still have these douchebags over here and the douchebag kids across the street and stuff. But my plan's not changing. I'm still gonna get the W, the win. Anyway, I'm still doing my Lawson too. Just talk about that. I do that tomorrow. But anyway, thermodynamic basics. Pressure is a collision of molecules in a closed area. There's pressure all around us. There's always pressure. It just goes to show how small you guys are and how big I am. Thanks. With that being said, let's get to it. There's atmospheric pressure, meaning the rotation of the planet, the electromagnetic force, gravity, the weak electromagnetic force, and strong electromagnetic force, another say. And magnetism creates the atmosphere, which causes the planet rotation, causes the moon to rotate around us, the earth core, blah, blah, blah. The sun itself giving off heat, causing gravity in the atmosphere, and we have atmospheric pressure which is in the international standards of unit or the system international unit or number, it is 101 pascals, 100 kilopascals, for someone call it. And you know what kilo mean? Thousands, actually, it's hundreds, thousands, whatever. 1 kilopixel equal to 1,000 pascals. It is, as I stated, international unit of standards. For America, we use pounds per force per square inch, which is 1 psi, and the atmosphere pressure is 6,895 kilopascals if you convert it. In other words, atmospheric pressure, the amount of molecules that's bouncing around in a closed area of the whole planet in one given area. If you use kilopascal, it is 1 Newton of area, which is 1 kPa or 1 kilopascals or 1,000 pascals because 1 pascal is pretty small. And if you use American standard, is 1 psi, which is pounds per square inch, which is 6,895 kilopascals, meaning that in a 1 square inch of our body is how much that atmospheric pressure is on that 1 inch of that area, surface area. And Pascal is usually used for hydraulics and atmospheric pressure rise. You're jumping up and down, you having gravity moving down you in per square inch, you have the atmospheric pressure. Uh, like I said, pressure is into more than molecules in the closed area colliding. Planet is a planet, does not matter, it's still a closed area. If you're using liquid or gases, it's more molecules, but when you use a solid, it's more stress because it's solid and you will know how much pressure it can take, which goes into blacksmithing or sheet metal fabricating or welding or black or whatever else they deal with metallurgy. Yep. And you know the acceleration of gravity is m/second square, meaning wherever the mass is divided by the square, which is freaking divided by the second, that's a square. So with that being said, weight is how much gravity using acceleration push down you. That's gravity. Mass is how much atoms you have in a subject or how much, atomic mass you have. It's always that. Mass and weight are totally different. Weight is just nothing more than gravity down pushing on you. It's how much gravity is pushing down on you. Mass is how much atomic mass you have. Totally different. When people say you got a large mass, I don't even get the joke. They might just say it'll have that and have a large gravity around them. Yeah. To get the freaking gravity, because you can use gravity for a well depth. Like I had to use gravity for my well depth because when I bought my house, they did not have the proper well depth on it, which means they lied to me, which means I have to sue these fools. But anyway, to get the gravity equation is gravity equal mass divided by seconds per squared per feet per square seconds, whatever, feet per second squared, basically. And to use this equation, you need to get an object, find out how much mass it have, and you can drop it from a fixed height. The time it takes to hit that bottom, you got the time, and you time that, and you divide that, you square that time it take to hit the bottom, and you divide it into the mass. That's the how much acceleration was working on it. But you also got the height level, which can variate. Yeah, that's my water. Pour my water on these parts. And force is a standard measurement of 1 Newton, meaning 1 kilogram times mass, which is feet per second squared. Basically, force is how much force is acting on an object. Since we are on Earth, there's always force acting on us, whether you're moving or not. To use this in a proper equation, I will say get the kilogram of an object, get the mass of an object, and get how much second is moving and hit another object. And then you can determine how much that object was this force, which is form of kinetic energy and potential energy, as well as inertial energy, which is a whole different set of math. I'm going off subject, but it's thermodynamics that deal with heat, deals with thermochemistry, with heating of molecules, or heating an object, heating a car, heating a refrigerator, whatever. Anyway, I'm out.